All right, this is solving absolute value inequalities. We're going to work through 3 different examples today. So here we go. The first problem, we need to isolate the absolute value before we can split it into its 2 separate solutions. And the way that to isolate the absolute value, which is right here, is I need to get rid of this minus 4. Well, the opposite of minus 4 is plus 4. So I'm going to add 4 to both sides. That brings me to this. The absolute value of 2x plus 3 is less than or equal to 9. And at this point, I can break it into 2 different solutions. I have 2x plus 3 is less than or equal to 9. And I have 2x plus 3 is greater than or equal to negative 9. Don't forget that you've got to flip this sign and change the sign of the right-hand side. So flip and change before we can go on. Give a little more room. Now I'm just going to solve these separately like a regular 2-stepper. Minus 3 minus 3. 2x is less than or equal to 3. No, it's not 3, is it? What is it? 6. Now I divide by 2. Now x is less than or equal to 3. So that's one solution. And we'll stick that on a graph in a minute. Over to this one. Minus 3 from both sides. 2x is bigger than or equal to negative 12. Divide by 2. X is bigger than or equal to negative 6. That is our second solution. Now, in terms of space, I'm going to draw a number line over here because they wanted us to graph our solution. And I can look at my numbers and say that I'm going to have to go between 3 and negative 6. So if I put 0 in the middle and do like 2, 4, 6, 8 in this direction, 2, 4, 6, 8 in that direction, you don't have to label every single hash mark. Whoops, that is a 4 and that is an 8. That should give us enough room. I'm going to change colors so we can see the dots. Over here, I'm going to have a closed dot at 3. There's my closed dot. And I'm going to shade to the left because it's less than. So I'm going to shade in that direction. Then I'm going to go to this one. I'm going to have a closed dot at negative 6, which is right here. X is bigger than or equal to negative 6, so I'm going to shade to the right. So this entire space in here, between these 2 solid dots, becomes my solution set. Now for problem number 2. Once again, I need to isolate the absolute value. There's nothing added to this absolute value, but there is a 5 that's being multiplied out front. So I'm going to divide both sides by 5. So the absolute value of 1/2 x plus 3 is bigger than 1, because 5 divided by 5 is 1. Well, lucky for me, at this point, I have the absolute value isolated, so I can split it into 2 solutions. The first one is 1/2 x plus 3 is bigger than 1, and 1/2 x plus 3 is less than negative 1. Remember, you've got to flip this sign, and you've got to do the opposite positive negative sign. So I'm going to solve them separately. These are like classic 2-step solutions in algebra. Subtract 3 from both sides. 1/2 x is bigger than negative 2. And now I could divide by 1/2, but I could also multiply by 2 because that's the same as the inverse operation here that we're looking for. So x is bigger than negative 4. There's one solution. Over here, I'm going to subtract 3 from both sides. 1/2 x is less than negative 4. And I'm going to multiply by 2. Both sides. X is less than negative 8. So now I can come over here to make my number line solution on the graph. And looking at my numbers, I have negative 4, negative 8. So I don't need any positive numbers at all. So it makes sense to put 0 all the way over here on the right. And if I go to 10, it should be plenty of room. So 2, 4, 6, 8, 10. Negative 10, negative 8, negative 6, negative 4, negative 2. Now I'm going to change colors so that we can see where the dots are going to be. Over here, I have an open dot at negative 4, and x is greater than negative 4, so I shade to the right. And over here, I have an open dot at negative 8, and it's less than, so I shade to the left. So this is an OR conjunction. The one we did before, if you look up to the top here, was an AND conjunction. And this one is OR. All right, if you need to review this, you can pause here and look over the examples again. But I'm going to go on to example 3, which is the trickiest one of the bunch. I have to isolate the absolute value, which is this thing right here, before I can split it into two solutions. So I need to move this plus 3. The opposite of plus 3 is minus 3. So now I have absolute, or negative 3 times the absolute value of 2 minus 5/4 x is less than or equal to negative 18. Now over here, they multiplied by 3, so, or negative 3. They multiplied by negative 3. So I'm going to divide both sides by negative 3. And we haven't seen this yet, but if you remember, something strange happens when you multiply or divide an absolute value by a negative number. And this sign has to reverse itself. It has to flip. So this, instead of less than or equal to, becomes greater than or equal to. Negative 18 over negative 3 is positive 6. And now I'm ready to split it into my two solutions. So let me go down the board a bit. I have 2 minus 5/4 x is bigger than or equal to 6, and 2 minus 5/4 x is less than or equal to negative 6. Make sure that you flip this and you get the opposite sign here. Now I can solve my two solutions separately. Minus 2 minus 2 minus 5/4 x is bigger than or equal to 4. And then if I think of this as a fraction here, this is really multiplication by negative 5 and division by 4. So if I want to do the opposite of that, I could multiply by negative 4 and divide by 5. Or in the world of fractions, you just use the reciprocal. But I have to do that on both sides. Okay, these cancel out and become 1, which is nice. So this is really x, and because I multiplied by negative, I have to flip this sign again. X is less than or equal to negative 16 over 5. Give me some more room. X is less than or equal to negative 3 and 1/5 is one answer right there. Over to the other one. Subtract 2 from both sides. Negative 5/4 x is less than or equal to negative 8. And now I'm going to use the reciprocal again. Negative 4/5. Negative 4/5. These become 1. You're left with 1x. Don't forget to flip the inequality again. Greater than or equal to. Positive 4 times 8 is 32 over 5. So x is bigger than or equal to 6 and 2/5. So now all that's left to do is to put this on a number line. So I'm going to give myself some more room. And down here, I'm going to go, I need both positive and negative numbers. So I'm going to put 0 in the middle. I've got to go as high as 7. So let's go 2, 4, 6, 8, 10. And as low as 4, 2, 4, 6, 8 is plenty of room. Negative 8, negative 4, 4, 8. That does it for the scale. So changing colors so we can see our dots. I'm going to have a closed dot at negative 3 1/5. Well, that's going to be negative 3 is right about here, so negative 3 1/5 about there. You don't have to be exact with these number lines. And it's less than or equal to, so I shade to the left. Then this dot over here is going to be a solid dot at 6 2/5, which is just about 6.5, but not quite. So 7, sort of right in here. Oh wait, 4, 6, yep, right in here. Closed dot at roughly 6 2/5, and that's greater than or equal to, so I shade to the right. Because these point away from each other, that is an OR conjunction. And there we have our solution and our graph.